Hey all, we're going to finish example 2 from class today. We were estimating, or approximating would be a better word, the area under the curve y equals x squared from 0 to 2. We started by using 2 right endpoint rectangles. Now we're going to use 4 right point rectangles. The rectangle width is, as it's always been, 1/2, right, for when we use 4 rectangles over an interval of 2, right? That never changes regardless of which kind of endpoints we're using, right? Just as in example 1, right? Width was 1/2. What changes is how we calculate our area sums, right? Our rectangle areas, right? Now, we were drawing examples in class, and you may not need to actually draw things out if I give you one of these problems, but again, I do think it's good to draw them out at least in the beginning so that you understand what we're doing, so that we understand what we're doing. All right, so if we use right-hand endpoints, remember that means that for each of these subintervals, 1, 2, 3, 4, we're using the rightmost point in the interval to determine the height of our rectangle, right? Here, there, there, and there. Oh, maybe we go even a little bit higher, right? To there. Okay. So again, as with 2 rectangles, clearly an overestimate for the area, but less an overestimate than before, right? It's not as big an overestimate. So let's see what we get. We have that the area is approximately equal to, well, remember, we know that the width is always going to be 1/2, right? Remember I mentioned in class, right, everything is going to be multiplied by 1/2, right? F of something times 1/2 plus f of the next thing times 1/2. We can just factor out that 1/2 if we want to out of the whole thing and just worry about adding the heights. So what's that going to be? Well, that's going to be f of 1/2, right, because we're using right endpoints, plus f of 1 plus f of 3/2 plus f of 2. Okay, well, that's the same thing as 1/2 times the quantity, 1/4, plus 1, plus 9/4, and then plus 4, right? Because we're squaring each of these, right? We're plugging each of these numbers into f of x, into x squared. So we add them all up and then multiply by 1/2. Don't forget about that 1/2. We're going to get, let's see, 1/4 plus 1 is 5/4 plus 9/4, 14/4. Can't do this all in my head. Plus 4, I guess that's 16/4, which I guess is 15/2. So I guess we're looking at 15/4. Right. 13, right? Just double checking, right? Right, 30/4 is 15/2, 15/4. Okay. 15/4, a little bit less than 4. Okay. So just pointing out that we know that this is an overestimate, and we know that the left endpoints were an underestimate. So I guess we've got that the true area under the curve from 0 to 2 is something between 7/4 and 15/4. Okay. Now the other thing I just want to point out is there's a little bit of a shortcut, not that much of a shortcut, but something kind of nice. If you take a look at the left endpoint, some of those values that we plugged into f might have seemed familiar. Note that there's considerable overlap between the left and right endpoints, right? In particular, these guys were all used in the right-hand endpoints, right? The only thing that wasn't used in the right-hand endpoint was the first value, f of 0, right? Because that was a left-hand value. Okay? All right, we saw these guys, once again, used right here. The only thing that wasn't used in the left endpoints was this guy, because that's always a right endpoint value. So just showing that if I ask you to do left and right-hand endpoints, then if you do the work for one, then you've probably done most of the work for the other too. You just have one more point to exclude, one more point to include, right? One more height, I guess you could say. All right. That's all I've got for you now. Thanks for watching.